2:30. William, Aiden. Julia. Did you break my 3-hole punch?
No, it's just broken when I picked it up. It's fixed now.
Oh, Sam, I'm gonna read like the analysis. I wonder what number is this? Yeah.
That's the review, which is 57.
Well, when he's walking out, we'll go
Yeah, that looks right. I didn't do this. Oh, I just did. I didn't actually do that. I guess. Yeah, but it's just the one on that little yeah, this is recent.
It's not very organized. How was your Halloween, Mr. Townsend? Did you pass out candy?
Halloween? Wasn't that yesterday?
Yes.
I don't know. I was at school all day.
No, it's 2 days ago.
Tuesday. Did you pass out candy to people? Or did you turn off all your lights?
Yeah, I was asleep.
You were asleep.
Yes.
Did you leave candy out for people?
No.
What?
Go
Do you
away.
live in a neighborhood?
Huh?
Do you live like in a neighborhood where
Yeah.
people would go? Trick-or-treating?
Yes.
That's so sad. Oh my god.
And he doesn't want to see children.
What time do you go to bed usually?
Yeah.
I don't know.
8.
You don't know?
What? Why?
I was just wondering.
What time do you go to bed?
It depends. Sometimes like 10 or like 11,
What time do you wake up?
around then. 7 usually.
Okay. Well, I get up at 5:15, so.
What does that point
Like
do to me?
9.
I don't know.
He's trying to make me look bad for when I go to bed.
I go to bed at 8 or 9, so you know.
Yeah, I went early 9:30.
I usually lay down about 7:30. Sleep by 8:30.
I'd rather go to bed early than wake up early and do my homework.
Yeah.
He's on the get home. That's good.
Y'all don't want me to be teaching with lack of sleep.
It slowly turns into 12.
You think I'm cranky now? Just wait. Okay, we need to move on here. So we have our next test coming up, not next class, but the class after. So we've got a couple things to kind of wrap up. We did some FRQs last time, and on the front of that, there was 3 of them. On the back, there was 2 of them. We did the 2 on the back together, and I'd ask you to do just one more of those with fidelity. So one of those front 3 you should feel pretty good about if you stuck it out. So I'd like to maybe start off with one more of those because there is no such thing as too much FRQ practice. All the justifications and knowing what they're looking for and knowing the process and recognizing mean value theorem and all that stuff gets easier the more of those that you see. So I will try to expose you to as much of that as we can. I will give you a chance to ask 1 or 2 last circuit questions from a couple classes ago. Again, there was a couple that were not worked out as videos, and I helped you out with a few more last time, but if there's still something that was not already done or not helpful or you didn't ask last time, I don't know why you wouldn't have asked by now, but just in case, I am asking you to turn that in, so I'm giving one last chance for that. Then finally, we will move on to the handouts you picked up. Or I will ask you to finish this 56, turn in 45 and 56, and then move on to the test review, which is what you guys picked up on your way in. So those 2 pages make up 57, and those are the test review. So, test review, some of you guys will move on to that faster than others, so just speaking very generally, it's structured the same way as some of our last test reviews, where it's one topic at a time. So I think the first topic is mean value theorem. Make sure you know the conditions, couple practice questions. Honestly, those are probably some of the harder questions on the whole review. And then a new topic, couple practice questions, remind you of a different topic, couple practice questions, and that helps you identify what it is that you are prepared for and not prepared for. And then there's like one super big F prime FRQ on the back with just about anything that could possibly be asked. But if you know how to look at those and read those, you can do that whole back page in like 3 minutes. So it looks like a lot, but it's not too bad. Okay, so as far as our FRQs go here, again, some of you guys did FRQ 1, some did 2, some did 3. I didn't force you to pick and choose which one you did, but I'm willing to go over one more with you up on the board. So you need to decide which one do you think you would benefit from the most help on. So you probably read or at least scanned all 3 of those last time to choose which one you wanted to do. But do you guys have a preference between FRQ 1, 2, or 3? Number 1? Okay. I would probably agree that 1's probably the hardest of 1, 2, and 3, but just because of one algebra step. So if you already did FRQ 1 and you checked your answers, you learned from your mistakes, you made the corrections you need to make, you don't have to follow along with this on this one unless you think that maybe you could be more efficient and you want to pick up on that. While we're doing this one, you should probably do number 2 or number 3 if you didn't do those yet. Okay, so FRQ 1 is a no calculator one. They give us a function and they want us to know the critical numbers of the function. So how do we find critical numbers? Okay, figure out where the first derivative is 0 or undefined. So you do have to take the derivative. Now you've got 2 options here. You could do product rule, which is what I'm going to do because I think it's easier. And you do have to know product rule, but in theory, if you want to cube this, it means take 2x plus 4 times 2x plus 4 times 2x plus 4 times an x minus 6. If you want to spend several minutes doing the algebra, distributing all that stuff, your derivative would be a little easier because you would just have to do power rule a couple times. But I'm going to do product rule here. So product rule says take the derivative of the first part. So bring the power down, lower the power by 1. It's got a chain rule component times 2 times the second part left alone, plus, and then the derivative of the second part times the first part left alone. Now, I want to talk about the scoring as we go along here because even though that's a messy derivative, being able to do that was already 2 of the 9 points. So without, you don't even have to simplify. That is the correct derivative, so that would get you the first 2 points. Okay, we can simplify just a little bit here. We could say 3 times 2 is 6. I've got an x minus 6, and I've got 2x plus 4s. Oh. That plus 2 is the points. That's confusing me. And then plus, I've got 3 2x plus 4s. Okay, so you guys just said this a second ago, but critical numbers, to find those is when the first derivative is 0 or undefined. Is this thing ever going to be undefined? Okay, how do we know that so fast? Right, you don't have, well, it's okay to have fractions, but you can't have x's in your denominators. So there's nowhere this is undefined, so all we need to do is figure out where it equals 0. And even if that seems easy to you, and you feel like you shouldn't need to write this step down, you need to write that step down because they give you 1 point for showing that you set the derivative equal to 0. Okay, here's the algebra step that I think is a little bit harder. It shouldn't be harder, but I realize that it is. We need to solve this. So you might be tempted to subtract this over, and you can try that, but then you're probably going to be, this is a cube, and then you're probably going to be stuck. And the next step is honestly maybe the easiest algebra thing you've ever learned. But if you can't see to use it, then it doesn't help that you can do it. So what do you think we should do algebraically? Yep, right.
Pull out the 2x plus 4 squared.
Right. This and this have a GCF. Together, that is a 2x plus 4 squared. That is the greatest common factor. It's easy for you to factor out a greatest common factor, but if you don't see that they have a greatest common factor and you don't think to pull it out, then it doesn't really do much. So this times this needs to give me all of this. So it's missing a 6x minus 6. I'm just going to distribute it. And then this distributed to this is supposed to give me that. So it's missing a single 2x plus 4. Okay, over here you can combine like terms. And now that it's something times something equals 0, if I can make this equal 0, that's a critical number. And or if I can make this equal 0, set that equal to 0 and solve. And they gave 2 more points here. So 1 for each. So that looks like it was pretty tough algebraically, but honestly, if you caught that GCF, then it wasn't too bad. Okay, any parts about A that you want me to review before we keep going? Okay, part B. For what values is G increasing? So again, it's probably going to take me a couple minutes to answer this, but if I'm interested in when G is increasing, should I be thinking about the function, first derivative, or second derivative? Okay, and this part A helps out a little bit. Critical numbers, they're not just things we randomly ask you to find. The reason why they're so important is these are the 2 places it might be changing direction. So you probably want to do a sign chart. Make sure you're adding enough information to this sign chart. What you got?
Calculators.
Oh, you brought them? Thank
That's
you.
me. At least I hope they're calculators. We'll see though.
They feel kind of empty.
Well, you know,
Did you
better make
empty them
$100
before you brought them
You
here?
can sell those at a pawn shop for
That sounds like that's your plan. You brought them to me empty.
Maybe so. Double check. Have a good day.
You too. Okay, so we got 2 critical numbers, the 2 places it might be changing direction, but to know what's going on here, we need to test around these. Like, I don't know, 0 would be a good one because that's pretty easy. 5, -3. And I know some of the shortcuts you guys take, and you're developing bad habits here. Don't just show me the x values, -3, 0, and 5. Tell me that they're getting placed in the first derivative. That will help you out sometimes. Sometimes it's not needed, and sometimes it is important. So I've got the derivative over here. So if I plugged in 0, I would get a positive times a negative, which would be negative. When the first derivative is negative, it's decreasing. If I plug in 5, I get a positive times a positive, which would be positive. When the first derivative is positive, it's increasing. And plugging in -3, this has to be positive because anything squared is positive. And a -3 makes this negative. A positive times a negative will be negative. So here's my sign chart with a lot of information. It shows the numbers I plugged in, it shows what I plugged them into, it shows why I think things are increasing and decreasing. But all of that to answer when is it increasing. So what is the answer to part B?
4 to 30.
Good. This is not just good for justification, it gives a quick little visual of what's going on. It's only increasing from 4 to infinity. Okay, they also said justify my answer. So how do I know it's increasing from 4 to infinity?
The chart that you drew, the line.
Okay, that's true, but let's try to just hone in. How did I know this one answer was increasing?
Because it changed direction. Or no.
Is that a positive slope?
Okay, so let's refer to the first derivative. The first derivative was,
5 or greater than 0.
yep. That's plenty justification. I think it's increasing during that time because the first derivative is positive during that time. Yeah.
So just drawing a line chart where you already have the first derivative of 5 is greater than 0 is not enough justification. You have to also write it.
Sometimes it can be, but in this case, no, because this you're telling me that you think it's increasing because at 5 it's greater than 0. But what about 4.5?
Okay.
Why is 4.5 part of your answer but not part of your justification? That becomes the problem. Okay, and then last one, identify the x-coordinates of the critical points which have a relative min. Justify your answer. So this line chart is paying off again because we can just glance at it and see that there is a relative min. Point, this was important. Where's the relative min going to be? X equals 4. We can see it right here. And why is that a relative min?
Because the first derivative goes from negative to positive.
Perfect. 1 point for the correct answer, 1 point for the justification. You can justify it in much, much, much less efficient ways. You just need to be careful. Sometimes when you guys try to write a sentence explaining it, your sentence better be comprehensive. You can't create holes in your logic. Similar to this one up here. This is not a good enough reasoning for part B because it doesn't explain why my answer was 4 to infinity and not 5 to infinity. Like, you would have to go further there. So
Will they take points off if you go from writing G to F? Because this question is over G of X.
that's a good question.
I do that.
The answer is I don't think they would count off on that because they don't try to punish you. They're not trying to be like extra unfair. But they're never going to put that in writing, so I would always try to use the correct notation. She was pointing out that in this function it was G, not F, so I really should have been using G prime, G prime, G prime. G prime is positive, G prime is negative, G prime is positive, not F. There was no F in this question, so not important enough to go back and change everything, but you should aim to be correct. Okay, anything to finish up that number 1? So, critical numbers, you need to know how to find them. Occasionally you need to see a GCF. That was the hardest algebra part there. Knowing where something's increasing, decreasing. This line chart gives you a quick visual. You've been practicing making that for a while now, and you're going to continue to make it in the next unit. Our next unit's very short because it's a lot of the same stuff, but that's important. And relative mins or relative maxes also got the information pretty quick from the sign chart. So if you can make the sign chart, you can get parts B and C. Okay, anything else about this first one before I put it away? Okay, so you should have done one of these 3 yesterday. And then we just did another one, so you should have 1 more to finish this page up. So I would like you to do that first. Or no, I'm sorry. If you don't have questions from the circuit, again, I said I would give you 1 or 2 more quick questions if there was something still holding you back. But if you do have 1 or 2 of those questions from the circuit, please go ahead and ask. Otherwise, move on to that last FRQ.
for number 10?
Is 10 not one I had worked out? It's not. Okay, good. Okay, you'll have to tell me which one 10 is because I don't have them numbered on here.
I think it's the first page, second one.
First page, second one. This one?
I think so.
Okay, is this what you guys got for number 10? Just to make sure the number's right?
Yep.
It is, okay. All right, find the intervals on which h of x is concave down. So if I care about concavity, I know its second derivative is concave down when the second derivative is negative. So like all of these questions, they're going to take a couple minutes, but it shouldn't take you a couple minutes to figure out what your plan needs to be. This is kind of nice. They already gave us the first derivative, so at least we only have to take the derivative one more time. So power rule, power rule, power rule, the derivative of the constant is 0. Okay, so similar to increasing, decreasing intervals around critical numbers are the only place it might be changing direction, so that's where it's going to change from increasing to decreasing or decreasing to increasing. Inflection points are when the concavity changes, and inflection points can only occur if they're a point on the graph and they make the second derivative 0 or undefined and the concavity changes. So hopefully this guy factors. Yeah, that looks like that factors, and that is true at these two values. Okay, did you get that far? So 3x equals 3 might be an inflection point. I'm putting the word maybe there, not because that's a real mathematical thing, but because it's not guaranteed to be an inflection point yet. Being equal to the second derivative, making the second derivative 0 is not enough. And same with this one. This one might be an inflection point. But these are the only two places that the concavity might change. So test something like 0 into the second derivative. We would get 0 minus 0 minus 9, which is negative. When the second derivative is negative, it's concave down. Try something to the right of 4 or 3, like 4. So maybe throw 4 into the second derivative. Now, notice we've got two representations of the second derivative. So you can plug 4 in here if you want to. I think that's a little harder to compute, whether that's positive or negative without a calculator. Plugging it in here is quite a bit easier. So if I plug in 4 here, it's positive. If I plug in 4 here, it's positive. And a positive times a positive is positive. So just keep that in mind. You can plug, these both say the same thing. This is a little easier to evaluate without a calculator though. Okay, and then maybe negative 2. That would make this negative, negative. A negative times a negative is positive. When the second derivative is positive, it's concave up. So, not exactly the same type of line chart because it's not showing increasing, decreasing. But just in case you needed this for a later question, concavity is changing here, so we can now say for sure that this is an inflection point. Concavity is changing here, so we can now officially call that an inflection point, in case you were looking for inflection points. But really, we just want to know where's concave down. So that looks to be between negative 3/2 and 3. It's the only times it's concave down. But of course, you need to understand why I found the x equals 3 and the x equals negative 3/2. These are the only two places the concavity might have been changing. I don't have to check the concavity more values here or between here or outside of here. If it was going to change concavity, it would do in those intervals that I tested. Okay. Anything else about that one? Okay. if you want to review that, I will add that to the website here in just a second. So, to move forward here, we've got I'd like you to do that last FRQ. The website has all of those worked out except the first one, but we did the first one together this morning, so that shouldn't be an issue anyway. It's also got the scoring guide, so use the scoring guide not just to check your answers, but to make sure that you're putting down the proper justifications, that there's not something that they're expecting you to list. So let me give you a few minutes to get going there, and then I'll come around and help. And I will open both of these things up in Google Classroom because I am asking you to turn these in between now and next Tuesday. Oh, Cooper, was that yours? Yeah. That's good. I didn't know who's left it behind. Okay, both 54 and 56 can both now be turned into Google Classroom as you finish.
I should know how to fix.
So for pilot one, you got 0 for 1.
Sixth.
Pilot before you have to do that. That's the one, right? You're right. Sorry. I think the worst case thing is yeah. I do.
On this one, does it have any, is there any values that equal?
Well, you are missing, when you took this derivative,
Oh, I need to do.
you need a chain rule there.
2 times 0. So you get 2 pi plus cosine of 2 pi.
Wait, then I know that too.
Yeah, so that is 2 pi plus 1.
2x17.
Mr. Townsend, is your test on Thursday or Friday? Because on your website it's saying it's the 12th.
It is Thursday.
Okay.
You might have to refresh that page.
Okay.
I was thinking that we could do it on Friday, but then that was only given one day and then another test. So it wasn't
Okay.
going to be enough time.
Gotcha.
One day
Well, the next unit is curve sketching, and it's like 99% the same stuff y'all are doing right here. Because you're just trying to, you take a function and you try to graph it accurately. But if you know where it's increasing, decreasing, you know where it's concave up, concave down. If you add a couple points by plugging into the function, you get a pretty accurate graph. So that's why the next unit is very easy if you have all this stuff down.
I'll sign up for advisory for 2 days next week so I can take the test because if you know, I won't be there on Thursday.
Okay.
Neither will Julia because it's the fashion
So
show.
if we're taking the derivative, right?
Julia messes all the time anyway.
She's been injured. I feel so bad for her.
Sorry, give me about 3 more minutes and I'll come around and help.
And do you have to change this? Yes.
Mason. This is the calculator that you asked for. So it's going to have charging cable, instruction book, and this is checked out to you just like any textbook. So if you lose it or damage it, they're going to charge you. And I think you probably need to keep this box with it too. So you might want to take this stuff home in a safe place, and then you know, just carry this around with you all year. So that is yours.
Thank you.
I can't believe you guys didn't like my meme today.
It was good. We just didn't comment, but
What was your justification? I think.
So, how can you tell the inflection point has to be on the graph? So how can you just like?
You just make sure that that x value exists on the function.
When would it ever exist if you're setting the equal to 0? I'd like to get the critical numbers. Like I'm on board with setting the, you can set the second derivative easy.
Okay. That's going to give you possible inflection points.
Yes.
Okay. but they may not be inflection points if the concavity doesn't change there.
Okay.
And they may not be inflection points if that's not really a point on the graph.
Okay. So the concavity does change.
Okay, is it also a point on the graph? Okay, you don't sound sure. Why?
So would you just like plug in 0 to the function and see if it,
See if it is undefined or not.
and it's not?
Are you plugging 0 into the derivative or the function?
Should be to the function.
Yeah, if you want to know if the point is on the graph, points
Okay.
come from functions.
Okay. So
See why you can't divide by 0 there?
Yeah, that makes
So
sense.
even though concavity is changing, that point's not going to be on the graph.
Okay.
So it might be something like concave up, concave, wait, that's concave up too. Concave down,
Okay.
but x equals 0 can't be an inflection point if it's not even a point.
Okay,
Right, the
that makes sense.
back or curve value. Wait, for
And they do sneak that in sometimes,
x equals 0.
where everything works except it's not really a point, and then that
Okay,
changes
that's
the
a
whole
little
answer.
tricky.
Yeah, it is
Okay.
tricky.
Oh, and then the second one, the video had like a chart instead of like a line.
So 6 by 4 equals.
Hey, that's awesome.
Yeah, I know what you're
But
talking
the thing
about,
is,
but
is the
what,
nursing program
so
isn't
I did this,
for
I worked
the
this out
main
yesterday and I started doing what you did.
They're
I think it's
in
x.
But you're supposed to find
Yeah,
what,
it's in Kansas City.
Hey, can
Which
you
would
please
be
do
cool.
this?
Yeah.
What are you trying to find in that
Like,
question?
My best friend is actually you, so like I wouldn't really.
okay, so this is gonna help me know maybe where it's increasing, decreasing. If it's a relative max,
Yeah,
then I guess I know where the max
Yeah, I
value
wouldn't
comes
know.
from. But
But
then you
like,
still have to
yeah.
plug that in to find the max value.
$64,000
So you're better off
scholarship,
saying
16,000 years.
Well,
Yeah,
what
so I was
they really,
like, okay.
what they really want you to
So
do in
I
that
honestly
question
like
is if it's asking for absolute
Like, you know, that could be cool. Like,
maximum value or minimum value,
You're gonna be great.
that is one of our theorems.
Yeah,
They
that's
don't have a lot
true.
of confidence in my friends.
Which one?
Sure. Like,
So now, what do we do? We have to.
Yeah.
Extreme. You want biggest and smallest, it's extreme.
Okay.
And what this does is it summarizes which numbers might be the biggest or
Oh,
smallest.
yeah.
Oh, I
Yeah, but the only
It's the
thing.
candidates test.
I
You
saw.
just test the critical numbers and the endpoints.
Patrick Bateman, Barbie.
My friend.
That's really what they'd like.
Okay.
And the nice thing about this is this candidates test is fine for justification. It makes the justification one easier.
His sister's nice.
Yeah.
Call me over as I
You
come
plug
around
that
and
into
suggest
the-
something I can help with.
The normal function, right?
Mhm.
For 0, I think you get 1.
So for,
You-
I found the slope that's guaranteed by this interval, right? I found the average slope over the interval. Then you like set the first derivative equal to that slope and solve, and whatever I get is the x value of first c.
No, yeah, that makes sense.
Anytime you have four terms, it's likely that's what you're thinking. Okay, what do you have to work with?
Because I have 0 to 1 as a pi equals 2
Actually, my
pi plus
grouping
1.
says
So
group
2
the
pi plus
first
1 minus
two
0
and the
is
last
1
one
pi plus
together.
0.
Take a GCF out of these two.
Because you get 2 pies.
Also factor out negative.
Oh, before it be.
GCF out of
I
these
think
two.
even though it's just like
You're gonna know factor by group is what is
And you add those.
this term,
so I
this
feel like
term.
it would be like
Now have a GCF of this.
Pi over 2.
And then this distributes to the first term, so we're gonna do that. And this distributes to this.
Okay, yeah, so the derivative is equal to the average slope, so I'm just gonna set it equal to 2. So the first
2
term
minus 1.
yeah, so just type 0. So it's gonna be
Did you try synthetic division by?
Yeah, sorry, just like,
It was so way.
Yeah,
I'm not a big
it is
zero.
though, right? Yes.
No, I didn't even do that.
So
-2 sine 2x.
for A, it's 2 minus 1.
Wait, yeah, if you just keep it going.
How do we justify that?
You add down first, make it 1 plus nothing, then you multiply it up there.
Yeah, it's coming
So
up.
isn't this right here?
Well, that's how you solve, that's when you just like to rotate it. Okay. And then you solve, and that's how you just do it.
You can just ask. Let's just check this out.
Mm-hmm.
But man, I'm so cold.
So I'm plugging 0
You say
Like normally like 5
to
or 4
find
seats.
what it will be here. And on the video it says one that
I was fine before last, like last year was 0, but I started having to like actually work it.
Okay.
And
Yeah, I
You're
was
plugging
like,
in 0,
yeah,
4,
like I would, well, first one, I had no pants.
and you're wanting it to
So,
figure
like,
out.
I had no pants, I just had
That's,
like one
you're not
pair
plugging it
jeans.
into Y,
So
you're plugging it
I'd
into
wear
Y
them
prime.
maybe just like twice a week, cause like they're jeans. But I can wear them every day, cause they're jeans. And I like wear shorts some days, and I'm so cold, and it's like sleeves. I'm the only people that says I'm not cold, except my
What's-
sleeves. Yeah.
What's another name for,
Yeah.
what's another name for
Boys.
F? What's another name for F
And
prime?
now I have two jeans. 4.
Your table is set up correctly, you want Y, but you're plugging it into Y prime. If you want a point or a value, you need to use the function. If you want to know if it's increasing, decreasing, or the slope, first derivative.
Okay.
Concavity, second derivative. The second isometric.
Is this enough to justify
That
using
is
the
the
candidates?
candidate set, as long as it's got both endpoints and the critical numbers, and yes, that's all the justification needed.
You don't need to put like something after you answer the semicolon. Semicolon, like way you just from the X for X equals 4 and then
Oh, well, I just said, it was like, here's my answer, and then here's my justification, but.
you really need this one to have the table again.
Yeah, the table is your justification. That's the nice thing about tree value theorem is
Just
it
to find the value.
makes a justification, and it tells you exactly what you need to do.
Sine of 0.
Well, you actually saw
Yeah, possible and possible. It's just that, I try not to use this acronym much because that's not real math. It's just that sometimes you guys assume it's an inflection point and we have to really, it's an inflection point, so I try to throw in the word like maybe or something. Just to help you, it's not really inflection point. But yeah, that's possible, possible point of inflection.
Like not the actual point.
You got anything I can help with? Please, can I help?
I think,
You know,
yeah.
maybe like just.
I'm figuring it out.
How do we
That's-
get that?
I think I got it, but she said that also sine of 2x equals 0, x could be 0.
Okay, we'll plug it in and see. If you plug in a 0 here, 2 times 0 is, what's the sign at 0?
Have you done?
That was where I had my problem. I don't know what sine is 0. Are you just talking about
yes.
the point 0? Because I thought you had to put these values into.
Is that?
Well, 0 is the value
Sign of-
too.
Yeah,
This
that's
is 0
right. So then you
radians.
factor it.
What's the point at 0 radians?
Factor 2
0.
No, the point.
So just 1 plus sine
X
of
again.
2x. And then you solve.
Okay, and sine is the y
You said
value,
1
so the
minus
sine
sine
of
of
0 is 0.
2x equal to 0. And you just solve that.
Do I have to put in both of those? And say this is the value of x whose existence is guaranteed by the mean value thing?
No, because it's an endpoint.
Okay.
We should include endpoints.
Oh yeah, I got next week is 2. Then after that, we'll set.
Then you'll graph it. That's also not the function, that's the second derivative.
Yeah, but
The function.
Yeah, because it's like you start at 0.
Okay, that's true.
So it's like that starting.
That doesn't guarantee.
Then when you go all the way around, it's 2 5.
Could have up to that.
did you get it? What'd you get?
Like x to the fourth.
How'd you get it?
The fourth degree, but it only has one degree. It could have up to 3 based on the degree, but it only has
Equals the.
But if you have
I should use what you say.
equals, what is that, what is C again?
It's derivative of.
Okay.
Oh, I see what you're saying.
That makes
For
sense.
negative 2 to be 0, it has to come back to
Yeah.
2 and has to come back. Yeah, I think you're right, but that helps.
So then you get to go to 0. So I think that just means 0.
If you're thinking, if you're also careful about the direction, where it's starting, like the.
Oh wait, no, I know what you do.
Yeah.
Okay, so you can take 5.
Sure. But you've already figured out where the numbers are, so you just make a sign chart, plug in a couple numbers in the concavity
And
of.
then it's like,
Yeah, but you can still solve this x. 'Cause this goes to 2, right? One.
Yeah.
Let's just say, on the test, if you do it that way,
Is it f of 5 or is
extra
it
time to
derivative?
back to
Wait,
the
yeah,
calculus
yeah.
rate, just to make sure it's.
I'm not even lying when I say I guessed on that entire test.
Yes, it's got anything I
and
can
then you have to
help
find
with.
what x is and y is.
Okay.
Or no, what, sorry, what y is and x is. So x is 0. And then.
No, erase it. And then.
What about when you get bored and you clean it? Go the other way with it.
Oh, yeah.
Just get a little bit of rubbing alcohol and get a little bit of it.
So the values for f prime does not exist is where the denominator is 0, right? Not where the numerator is 0. If it still exists, it just equals 0.
Good answer. Yep. There's more. I think. Yeah, I think 0 and over 2.
Oh, yeah.
So it has to be between. So, with room still. Between 0, so.
So for a, you got x equals 0 and x equals square
We're
root of
done.
negative
Yes.
1/4. Or I. So I took the numerator and so I got negative 4x squared minus 1 equals 0. Negative 4x squared equals 1. X squared
If you-
equals 1 over negative 4. So square root of negative 1. So does that count? But if I plug that back in, that would be the value for y, and the values for x. Well, it can exist, it's imaginary. Right? Okay. Okay, the only thing that's on there is f prime is not listed x equals 0, so I'll just get rid of that.
Wait, no, 16. Oh, 16. Okay, I got no solution to it first, but then it has to match up with this. Okay. So, what was I doing? I don't know. Did you get through that I did differently?
Square minus one.
Something that I messed up on that doesn't really affect the rest.
Okay, that's what I got.
And then what values does it not have? Zero? Is it fine? Or what is that? Or you said the top
Because to
doesn't work,
get
you
that
can't
from
self.
what we've got, we would have to have it be negative 4
So,
x to the
do you think that has to be good for the
minus.
Okay, you guys still have 40 minutes. Does anybody have something I can come help you with?
Is that the rest of that?
A couple of those are pretty tough. Like you really have to dig deep to figure out what they want you to do.
So that's what I was gonna do, but I didn't put the denominator, and that's when I realized that when set people to, set the denominator equal to 0, and then have the denominator. Which means I also use
A
it.
fraction, the numerator can be 0 in a fraction.
do that, it's just like energy to power rule.
0 divided by 5 is fine, it's 0. 0 divided by 8 is
Negative
0. Your numerator can be 0, it's your denominator that's
the
the problem.
negative
So you shouldn't even be testing.
Yeah, that's probably what I should
there,
have gotten.
and then it.
Something always happens, right?
Yeah, you can see it. It took, that took me a second. I thought it was a bunch of different. Well, because I think I just want to do around there. Oh, I can see if it's the one other side, and then I didn't write it down there, it said that it was part of that. Oh, I see. So it was positive, yeah. And then I could take the square root.
Question? Good, okay?
So when you get like 2 negative 2, so it's square root.
Yeah.
And so it's really big.
I don't think so, because I think 0, right? You have to plug in 0, or no? I'll check. Is 0 a critical number? Okay. No, okay, but is it decreasing with time? Oh, well then, I think it's the thing. I think you're right.
For 3A, when it says it doesn't exist, like you can't put the numerator to 0.
On this one.
Mm-hmm.
You
Yeah.
just do the denominator.
Yeah, I just, so this is where I got confused, and we were already with that number,
Yeah.
which is stupid.
Because it only went to 0, because it didn't go, well,
I never used it.
But,
I don't know.
so on the answer
it's
sheet,
weird.
Okay.
So
Oh, because I forgot to, once I got the question wrong, so I put it over there.
Oh, okay.
Yeah.
Other experts to do the blind test. To make it imaginary for the
Yeah, but you shouldn't, I agree, but you shouldn't be plugging in imaginary numbers for your X value.
We don't have an imaginary numbers, but when it equals to numbers.
Right. Yeah. Okay.
Yes.
So I figured out the thing, but the B keeps thinking about the first one.
Let me find.
Does that work?
No, right here, this doesn't work. You went from 4x plus a, and it looks like in place of x, you put 4x plus a. Well, x is not gonna be the same thing as 4x plus something unless, well, there's no way that's gonna work because of the plus something. I guess if the a was 0 and the x was 0, that would work, but let me see if I can. I just started playing with these yesterday again, but right here I took the derivative, got that. And then the derivative, if this is the equation of the tangent line,
Oh, it has to be 3.
it has to be 3 because it's the slope, yeah.
But it has to be 3 when x is 1, so that narrows it down to where you can solve for a.
Is this what I was missing for this?
Yes, those.
Yeah, this part. I'll try to remember that.
No, it's fine. I got it right now.
Mr. Townsend,
Yes.
for the circuit, I did some extra work on a separate piece of paper, but I forgot to number any of it.
That's fine. Just include it,
Include it.
just in case.
What did you say for BD?
I said. I said yeah. Cause the first derivative to the left of 0, because second derivative, 2 over x squared, right? So where the denominator is 0, that is 0. So I said that was an inflection point, and
X equals
then.
0 is undefined, and an inflection point has to be.
Thinking of something else, so for your inflection point, does it have to be differentiable, like?
It does not necessarily, well, an inflection point is going to occur when either this or this. So this is not differentiable. If you're talking about the second derivative, you know which thing you were talking about. So this is how you find the places where it might be inflection points. You still have to make sure it's a point on the function, and you still have to make sure the concavity is changing.
Okay, wasn't there something else that was, it has to be differentiable,
And
that
the
you would
answer
said
is
it would say it in the
did
question?
Mean value theorem only works if it's differentiable.
That's probably the thing.
Let's see, like, if you did
It doesn't.
if you're thinking of mean value theorem says that the average rate of change is equal, the instantaneous rate of change is equal to the average rate of change at least once. But do you see how this is not differentiable because it's a cusp?
Yeah.
So sometimes this slope is positive and sometimes it's negative, but if it's not differentiable, then it never got to be 0. That's why mean value theorem doesn't hold up there. That's what I'm guessing you're thinking of. I'm not sure though.
Yeah. So the answer is no. Is it yes or no? Yes. Why is it yes? I thought we just said. It doesn't exist. Does it? See? It doesn't exist. If you plug it in, it'll be 0 for 0. Plug it into this. So if it doesn't exist, it's not a thing. Yeah.
Okay, you guys still have close to 30 minutes, so still a lot of time to get some help if you need it.
So the only conditions for the mean value theorem is that it has to be continuous and differentiable over the interval, right?
You have to be a little more specific. It has to be continuous over the closed interval, so include the endpoints, brackets,
Right.
and differentiable over the open interval, which is parentheses. I did not realize that the answers and help videos were not on the website yet for the test review, so I did just add those, but you'll need to refresh the page for them to show up. So again, we've got our test coming up 2 classes from now, so next class we will be focused only on the test review. Between now and then, you need to make sure that you finish up and feel good about 54 and 56. And you can see in your homework, it asks you to move along with the test review, but there's not a set number of the test review I'm expecting you to have done. It should be proportional to how well you feel about this. If you feel like you could take the test right now, it's probably fine to do very little of the test review until next class. If you feel like you're far away from being prepared from this test, you probably should do half or more of the test review before next class. At the very least, start identifying all the stuff that you're good with, so that when I see you one more time before the test, you'll know what it is I can help with.
Did Celeste find a dance partner finally?
I don't know, I have to ask her.
Isn't that this
She
one?
did.
Push right.
I think you would have done great, you should have done it. I would be cheering you on. I'm not even going, but I really want.
Why would you not go?
I have virtual advising, I don't really feel like coming to school every day. Probably just
She
sleep.
should go.
We'll see.
You seem like you would like pep rallies.
I don't like talking to people. Like lots of people.
That's all you did in class last year was talk to people.
Last year, there was never time to talk last year.
Lots of time to talk.
No.
There's a lot more time to talk in pre-cal than there is in calculus.
Maybe. I feel like you always taught like the entire class last year though, but like this year it's like lots of time to just like work, so then you can talk, I guess, but about math. I guess I just don't like being around like a bunch of people that I don't know. Like I'm never around.
Or like, you know, going to school somewhere like Michigan where you don't know anybody.
That would be fine, cause
Where are you applying in
trust.
Michigan?
What?
Where are you applying in Michigan?
University of Michigan, the
Oh.
Ann Arbor one.
Nice.
Yep.
Yeah, I'm applying to Michigan Tech, and I really don't want to go.
Oh, yeah.
It's so cold.
See, I love the cold. Like the weather right now makes me so happy.
No.
Your face.
Me? Oh, I don't care. Weather's fine to me.
Does weather not bother you?
Mm-mm. My wife hates it though. She's convinced she's depressed this time of year because of the weather.
Would you prefer to be hot,
Yeah,
like hot
that
weather or
was
cold weather?
cooler.
If you had to choose.
What am I doing?
You're outside.
Doing what?
Activities.
Okay, well, I just go inside.
It's avoiding the question.
I don't know. In the summer, I don't like it because it's too hot, and I feel like I have to take a shower every 2 hours if I'm doing yard work.
That's fair.
But in the winter, I'm not trying to stay outside either.
So you're just like an indoor guy.
Yeah. Shelter. You need that to survive. No, I don't know. It just depends. I used to play golf in the snow, so,
That's fun.
but I had a motivation to be outside.
Yeah. It must be hard to find your golf ball. You use a golf ball and it's in the snow. You
Just
have
hit it
to-
straight, and then you just walk right to it.
Like, it's that easy.
Well, if you don't want to have to look for your ball, just hit it straight.
No, I'm a golfer. Let me show you my bowling ball. I just got it yesterday.
So you bowl, you play golf,
And I play basketball.
and you Photoshop.
Oh my gosh, no, I do not. It was look at it, it's all black. And then it has neon. It's pretty sick.
Are those like those green things like fit your finger size
Yeah,
or whatever?
yeah.
Huh.
For spinning. I'm gonna find a live picture of the fish so I can prove to you that it was not photoshopped.
Well, I mean, you might have caught them in the net or something.
No, you can't. That's just not how that works. Netting the fish is like harder than actually catching it.
Or you throw a firecracker in the water.
Oh my gosh, and kill it.
No, it just stuns them. They float to the top for a minute.
Really?
I think so.
I don't know.
Yeah, they do.
I remember watching something on Shark Week where like you can turn the shark upside down and then they're like hypnotized and they just like float.
I won't try that.
So I put 11
I've heard you're supposed to punch them in the eye too, but
I thought it was the nose.
the
So I was
nose.
like, oh,
I think both work.
I'll just solve it as a system of equations.
Soft, soft tissue.
With this stupid
I think I would just swim to
equation.
one
Well, I
of
like,
those.
didn't work on my Christmas list.
I don't think our.
You work until you get stuck. I'll look at it and give you a hint though.
Okay, this is a live picture. You can tell that it's
I don't know.
Oh, yeah.
Who else would catch it?
That guy in
That's
the
my brother. He's a worse fisher than I am. Guess where he's at school? No, he's in college.
Substitution, maybe is.
I'm working on
I don't
my
know.
Christmas list.
He goes to USC.
USC.
What do you put?
University of Southern California.
Make it.
Oh, I was gonna say South Carolina.
I feel really bad because this year I have to ask for a laptop because I don't have a laptop. and I
I'm
have to
doing,
college.
yeah, I'm doing that in the summer after I get all my grad money, when I send my grad
Did
report.
you get the answer?
I'm sending grad cards to acquaintances,
yeah.
like, everyone is getting a grad
Well,
card.
so I wish you got that in my mind. And that's the day of graduating. So I'm like,
It's amazing, it's just.
Yeah, I'm getting grad money and then my birthday is in July, so then I'm like.
Yeah, the wording, I know, pretty good. I'm not trying to make something.
Yeah.
Yeah. It's a lot less.
So I'm just gonna use the bedding I have in my bed now, cause I just got new bedding.
Well, I don't think most dorms have those.
Oh, yeah, well, it's not, it's just,
Oh, yeah.
I'm gonna change, I'm gonna get new sheets, so I can do the same today. That's what I meant. I'm just thinking.
I went to Arkansas summer for like governor's school, so I had to buy.
Yeah, but global warming, the ocean's gonna be.
Yeah.
It's gonna be starting soon.
You did what? Really?
And sharp.
These are hard,
Yeah.
especially this one. I struggled with that one, I think. Yeah. Well, part of what I don't, well, you haven't even tried it, but what I don't like about it is it's talking about a full year. So I don't know if that's 0 to 12 or 1 to 12, and every year, like
It has
months.
to be 1 to 12, right?
I don't know. I have to work it every year to remember what they even want you to do, but
All of them.
I wish they would be a little bit
Probably
clearer
not all of
there.
them, because some of them were due yesterday. I don't really know.
Actually, I'd probably say
All mine are.
0 to 12. And if the answer's between 0 and 1, I would know it was during the first month. But again, that's just a guess because I can't even remember. I don't like how big it is. But again, the front page is probably some of the harder questions. You might jump around a little bit.
Yeah.
Second page questions are much faster.
You got one grad.
Hey, what is it?
You got the slope as
First
well.
page is hardest.
Wow. I know. It's even in like 4 months, I swear.
That's true. Okay, so you would do one minus F of A.
Guys, how do you feel about this?
So 10 minus 32. 32 minus 10.
Okay, you're down to 10 class minutes now.
It's the same though. Like you can just, you can.
Oh, that's right there.
I thought
Would you like
that's
to
what you
explain
said.
What do you mean? I listed like 40 steps there.
It makes more sense when you verbally say. Don't just read what you wrote.
Well, then that is
I knew
what you
you were about to do that.
I wasn't, but
That could sound
I like the
good.
idea.
No.
Find the value that satisfies the mean value theorem. So you have to know mean value theorem is when the derivative equals the slope. Instantaneous rate of change equals average rate of change. So find the derivative.
Would you just take the derivative of that? Like with the letters?
A and B are just numbers. So the derivative would be 4x plus a. Okay, like this is number 4.
Yeah.
Okay, and then what?
I don't know. It's you use 0 and 2.
Okay.
4. So it'd be like 4x plus.
Sorry, I thought you were looking at a different question, but.
Well,
Yeah, I was looking at number 5 at first.
Okay, so the trick to that is, do you see the other equation?
Yeah, that's,
What's the other equation?
Two voices?
Tangent line,
Two.
What's its equation?
3x plus 4, y equals 3.
So, what is a tangent line?
Like where the slope equals. Is it just this? I forgot.
Okay, so you have the derivative as 2x plus a.
Well, for this
Yes.
you do
Okay.
3 minus 1.
What is the derivative
Minus
Okay.
that backwards, but
at any time?
you get different values at the top.
Did you get the same derivative? Yes? Yeah.
Okay, that's true, but how about when x is 1? When x is 1, what is the derivative?
2 plus a. 2.
Wait, why is it 2x%?
You plug it into,
Oh, it should be
the
4.
derivative,
Oh,
right? Or do you
yeah.
plug it into the function? Oh, that's what I did wrong.
Okay, but what numerical value is the derivative equal to when x equals 1? I already plugged in x equals 1.
Numerical value.
When you write an equation of a tangent line, where does the slope come from?
Like 3 to x. Y line.
What's the slope of this?
3.
Okay, this is the equation of the tangent line when x equals. It's in the problem.
Oh, x equals 1.
Okay, so when x equals 1, this is the tangent line equation. So the slope at x equals 1 is 3, and slope
Is the derivative.
is the same thing as derivative.
Okay.
So that gets you a.
Okay.
Right? Normally you have to make this equation line, tangent line, and the slope comes from the derivative. But now you're going the other way. You're just saying, well, if this is the tangent line when x equals 1, when x equals 1, the slope is 3, so the derivative must be 3.
Okay.
And that gets you a. And then that makes it a little bit easier to find the second one because you've got some more information to go with.
This one we're trying to
So are
find.
you plugging in?
So I did the treatment of that on the left side, and f of a minus 1. And it's just,
Okay, we plug in 2 for x.
yes.
Yeah, there's a lot of
Got you.
left
Well, instead of saying f of a,
and
you could just actually write the function with a plugged in. So instead of f of a, you could do 2a squared plus 3a plus 5. And then you've got an equation that you can solve for a.
Oh. That makes sense. So we put 7 equals. I don't remember.
Okay, guys, we've got 5 minutes, so probably finish up the question you're on. Again, everything, I'll verbalize it again, but it's all written up on the board. There's 2 assignments I want turned in the Google Classroom before next class. Both of those should be finished now based on having you do those for homework a night or 2 already, / questions or 2 once or twice already. So 54 and 56 are the ones that you need to have turned in to still get full credit. And then please do as much of the test review as you have time for. If you've got something going on during advisory today, that's fine, I get it. But if you don't, try to use that time to do a little bit more of the review. You know you're going to have to do the whole thing anyway. And of course, please try to utilize the solutions and video solutions as much as possible. You will have the entire class period on Tuesday to ask questions and study. But honestly, I don't know if that's enough time if you haven't narrowed down some of the topics to know what you need help with. So Again, if you're feeling prepared like you can take the test, you probably need to do less of the test review between now and Tuesday, but if you're feeling like you're falling behind or worried about it, you should probably do maybe all of it so that you know exactly what it is you need help with, and you will for sure have time to get all the help you need on Tuesday. But only you know exactly where you're at, so you need to take on that responsibility.
No, I am gonna present this on my TV. This is the closed section. There's like a lot on this list, but